Hello everyone, welcome back to the new video. Today I will talk about the boiler corrosion and the water specifications. There are majorly two types of boilers, the fire tube and the water tube. These have been named based on the material that passes through the tubes in the boiler. In a fire tube, it is the fuel which passes inside the tube and the water flows around it. In the water tube, it is the water that passes inside the tube and the fuel flows around it. As a result, although the elements remain the same, the manner in which they move inside the boiler is different. Hence, if you look at an article talking about the types of corrosion in boiler, you will find mention of types such as general, pitting, acid, galvanic, etc. It is indeed true that you will find these types in both the boilers, but the manner in which this corrosion happens is different. For example, because the water flows inside the tubes, the chances of pitting aqueous corrosion are more outside the tube and in the internal regions of the fire tube boiler. On the other hand, in water tube, the water flows inside the tubes. Hence, the incidence of aqueous corrosion is more in the internal regions of this tube. Further, the fuel gases may cause corrosion related to high temperatures, and this corrosion is now going to be more in the tubes in fire tube and outside the tubes in water tube. Further, the fuel gases will also cause the corrosion of the internal parts of the boiler itself. Thus, if the materials used for the tubes in fire tube and water tube are different, then the points in this construction where you are more likely to find the corrosion will differ. For example, if you use the same material at the bottom and at the top, the same material is going to encounter water at a lower temperature and water or steam at a higher temperature. Hence, the tube at the upper level will probably encounter a different type of corrosion than the tube at the lower temperature. This is true for the water tube as well. Hence, the water quality is really stressed upon in case of boilers. If the boiler has steel parts, then a general corrosion is represented by the intersection of the cathodic reaction and the anodic reaction of Fe. The red line indicates the corrosion current density. The boiler water specifications are given here as an example. Here they have talked about the pH as well as elements such as silicic acid, phosphates and sodium sulfide. If suppose the boiler water has an additional oxygen there, then the cathodic branch will move to a higher corrosion current density. To battle this, usually sodium sulfite is added. This will react with oxygen to form a compound that can be removed easily, leading to a reduced oxygen content. This reduced oxygen content is indicated by a shift in the cathodic branch to a lower corrosion current density, and this usually is lower than the original value itself. Thus, sodium sulfide or the addition of oxygen scavengers can be related to the electrochemistry, and the proper selection of the amount can be done by analyzing the electrochemical nature and formulating the correct contents. Further, there is the concept of silicic acid. Now, this may not seem related to any other parameter, but in fact it is related to the pH. The pH of the boiler in the specifications is 9 to 10. Now, silicic acid in a pH below 9 is present in the form of hydroxide or silicic acid. Above pH 9, it dissociates to give a hydrogen ion and an anion. This means that above pH 9, there may be formations of localized acidic environments due to such hydrogen ions. These may contribute to a certain extent to the acid corrosion that occurs in the boilers. I have talked more about how to tackle this problem in my course called Science of Chemical Treatment coming up on Monday. If you wish to attend, please contact me for additional information. I will also talk about the role of phosphate, sodium sulfides in more detail with respect to their chemistries, and the chemical treatment in other industries such as oil and gas and refineries will also be included. Please contact me for further information. I will put up a review of this course in the next video. Thank you. Please do like, comment, share and subscribe.